Continuing, right now we should know how to find the midpoint of a line segment. We should be able to talk about a line segment being bisected, and given a midpoint and endpoint, you should be able to find the endpoint. So now what we need to do is we need to figure out how to measure a line segment on a coordinate plane, which finding the length of a line segment is the same thing as finding its distance, which is going to bring us to the distance formula. But before we can do the distance formula, we need to remember how to simplify radicals. So, our rule for writing something in simplest radical form is to remember, if you have the product of two things underneath the radical sign, you can separate it, kind of like I did with that last one with the square root of 16 times the square root of 2. You can separate it apart and then simplify it as such. So let's go ahead and do the square root of 24 together. In my brain, I'm trying to find the largest perfect square that divides into 24. What are my perfect squares? 4, 9, 16, 25, 36, 49, what's next? 64, 81, 100. Out of that set of numbers, which one of those divides into 24? 4. Any other one? No. Okay, good. So, let's make our branches with 4. 4 times what is 24? 6. All right. So just like the rule said, I'm going to put square roots over both of those numbers. The square root of 4 simplifies to 2. Is the square root of 6 a perfect square? No. So I'm just going to leave it the square root of 6. So the square root of 24 simplifies to 2 square root 6.
Do we have to do that now where you like draw the 2 arrows with the 2 square roots?
To get to there?
Yeah.
No. If you can just get to it, that's
Alright.
fine. Okay. Now let's go over to 90. Out of these numbers up here, which ones divide into 90? 9 times 10. Can I divide 10 by any other of these numbers? No, so that's probably the route I want to go. So let's make our 2 branches with 9 and 10. Put square roots over both. What would that then simplify to? 3 square root 10. Good. I usually try to get in the habit of putting the perfect square first, because then it just kind of works out nicely how it comes down as your actual solution. Okay? All right, so we're going to pause. The reason why we want to be able to simplify radicals is because our distance formula is one big radical. Here's your fancy distance formula. Please jot this down. I will give you some time. So AB, remember AB with nothing above it means we're asking for the distance between A and B, or the length of line segment A and B. We're just using A and B just as a generic 2 letters, any 2 letters. So to find the distance between 2 points, we're going to take the square root of the following. Yeah, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So unlike the midpoint formula where we're adding x's and adding y's, in the distance formula you are subtracting x's and subtracting y's. Okay? Again, it does not matter which point you make the second x or the first x. You just need to make sure you're consistent on both parts. Okay? All right, so let's go ahead and do this example. We're going to find the length of RS when R is 2 and 3, and S has the coordinates 4, -1. So me personally, what I like to do is I like to write above these x sub 1, y sub 1. I'm going to make that 0.1 because it's the first point listed. If you don't want to make that one 0.1, you can make the other one 0.1. That's up to you. And then I'm going to label this as x sub 2, y sub 2, just to keep myself organized. So now it's just a matter of plugging it into the formula. Instead of AB, I'm going to use the letters RS. So RS is equal to the square root of parenthesis Okay, x sub 2. What number is my x sub 2? 4. Good. So 4 minus my x sub 1. 2. Close your parentheses, square it. Do not do 4 minus negative 1. My formula does not say to do x sub 2 minus y sub 2. It's x sub 2 minus x sub 1. And then we're going to add to it parenthesis. Now let's do the same thing for my y's. What is my y sub 2? Negative 1 minus 3. Close it, square it. Now it's just simple math, hopefully. What is 4 minus 2 inside my parentheses here? 2. Okay, so we end up with 2 squared plus, what's negative 1 minus 3? Negative 4 squared. 2 squared is 4. Now be careful here. These always should end up positive answers, right? Because squaring a negative should always make it become a positive. If you write a negative down here in this third line, it means you do not do that correctly. Negative 4 squared is 16. 4 plus 16 is 20. Is that a perfect square?
No.
So what do I need to do? Simplify it. So what are my simplifyings?
4 square root of 5.
So the square root of 4 and the square root of 5, which would go to,
2 squared.
good. So my final answer, RS equals 2 square root 5. Okay? All right. Last thing is we're going to do the same thing. It's just now we're going to incorporate it all into a graph. Is everybody ready? All right. So let's go ahead and start plotting some points. Plot point J. 6, negative 2. It's right about here. Point J. Negative 2, 4. So negative 2, 4 is M. All right, plot points J and M on the parietal coordinate plane. Done. Connect. Actually, I'm going to use my straight edge tool. And I know I'm getting a nice straight line. There we go. All right, so there's my line. We need to calculate the midpoint and then find the length. So let's remember, how do we find midpoint again? Midpoint is equal to, what are we going to do? Add the x's, divide by 2. Add the y's, divide by 2. What are my x's up here in my ordered pairs? Good, so 6 plus negative 2 divided by 2. And my y's are negative 2 plus 4 divided by 2. Okay, let's do some mental math. 6 plus negative 2 is 4 divided by 2 is 2. Negative 2 plus 4 is 2. Divided by 2 is 1. So there's my midpoint. Can you plot that? Hopefully it falls on your line. Okay, so there's my midpoint. Now let's find the length of JM. So JM is equal to the square root of, do you want J or M to be 0.1? J? So x sub 1, y sub 1, x sub 2, y sub 2. So what's going to go inside the first set of parentheses for distance formula? Good. Negative 2 minus 6 squared plus, what's in the second set? 4 minus a negative 2, which really would go to a plus, right? Okay. Let's do some mental math. Negative 2 minus 6 is negative 8 squared. Perfect. 4 plus 2 is 6 squared. 36. What's 64 plus 36? Ooh, this is nice. Nope, even better.
100.
Why is that nice?
Because it's
Because it's
a perfect
a perfect square, so my final answer is going to be 10. Good. I'll write it up here. So JM is equal to 10. Done.